Hi, hello, good evening, one and all. Welcome to the session. Can anybody confirm about audio and video? Hi, everyone. Hi, hello, good evening, one and all. Welcome to the session. Can anybody confirm? Okay. I think the audio video seems to be fine. So let's move on to the today's session. Right. So can you please let me know your presence, my dear? So in the last series, we have discussed some questions on machines. I tried to put some, I tried to bring some important questions or different questions from transformer and induction machine and then DC machine. Okay, okay. So due to some technical reasons, the Saturday session was not planned. So let's see here. In this session or in this series, I'm going to take up the subject called electrical measurements, and here I'm going to take up the power measurement. So first we will be discussing about DC power measurement, and then later single phase power measurement, and then later three phase power measurement. This is very important when it comes to GATE and ESE examination. Power measurement is very important topic. Okay, so when it comes to ESE, there will be, you can expect a question from ammeter voltmeter method or voltmeter ammeter method, and also, you know, and also single phase power or otherwise three phase power. When it comes to gate, they will be asking question on three phase power measurement, especially 2 watt meter method, 2 watt meter method based questions you can expect. Okay, so let's see here. DC power measurement. Okay, so here AV method is nothing but ammeter and voltmeter. Ammeter and voltmeter. VA method is nothing but voltmeter and ammeter. So which means ammeter is first, voltmeter is next. If you start from the supply side, ammeter is first connected and then voltmeter is connected. Similarly, voltmeter VA method is nothing but voltmeter ammeter method. So voltmeter is first. After the supply, voltmeter is connected, and then the next ammeter is connected. Or otherwise, in another way also we can say. Okay. So we want to measure the power. Power at a particular load, right? Power at a particular load. Okay. So generally this voltmeter will be on load side. This voltmeter will be on load side. Okay. Generally between the source and load, what will be the things? Generally we'll be having connecting wires, right? Between the source and load, you'll be having connecting wires. So I wanted to measure the voltage across the load. I wanted to measure the current flowing through the load. So to measure the current flowing through the load, I am placing an ammeter. To measure the voltage across the load, we are going to place voltmeter. So here, if ammeter voltmeter method, in this method, voltmeter is near to load or otherwise on the load side. Similarly, ammeter is on the load side. Ammeter in VA method, ammeter is on load side. So let's see how it is going to be connected, how we are going to solve this method, or how we are going to solve this one to measure the DC power. We will move on. Okay. All right. So let's move on. Before moving on to the session, there is a small introduction about myself. My name is Naveen Kollapalli. I have 11 plus years of experience in teaching. Most of the times I'll be teaching electric circuits, machines, measurements, and power systems. Okay, right. I taught more than 20,000 students since 2012, and I did my masters in electric power system from JNTU Hyderabad. I cracked GATE and State Public Service Commission examinations too. Okay, all right. So I think there is a interviews, mock interviews are going on at BYJU'S exam prep platform. Okay, if you have qualified in ESE mains, then you can attempt this one. I sincerely recommend. I strongly recommend you to attempt this one because it will help you to crack the interview part. Okay, the mock interviews we are arranging here. Right. So moving on here. This is ammeter voltmeter method. Ammeter voltmeter method. Okay. So see here. if you look at DC power, generally we can write it as voltage into current. He is asking to calculate. If I have a supply here, this supply is going to drive a current through this load. Generally, we will be having a voltage source, and to that voltage source, I am connecting a load. So that load is having a resistance of RL. So load resistance. Now what I wanted to do is I wanted to measure the power consumption by this load. So to measure the power consumption by this load, I just need to calculate voltage across the load, and I just need to calculate current flowing through the load. So this current flowing through the load and voltage across the load. Now to measure the voltage across the load, we have placed this voltmeter. And to measure the current flowing through the load, we have placed this ammeter. To measure the current flowing through the load, we have placed this ammeter. Okay. Let us see whether the meters are measuring their actual values or not. Ammeter is placed to measure the load current. But let us see whether it is measuring load current or not. Voltmeter is placed to measure the load voltage. Let us see whether it is measuring load voltage or not. Okay. So from that we will come to know, what amount of power will be indicated by these meters. Okay. So here the current flowing through the load is load IL, and the voltage across the load is going to be, you can take it as VL. Now if you write a KVL, this voltmeter reading will be is equals to VL. Voltmeter reading is equals to VL, because if you can write it as plus VM and minus VL is equal to 0. So you will get voltmeter reading is equals to VL. And coming to this one, ammeter reading, this supply is going to drive a current I, and that current is flowing through the ammeter. I can mention that current as a current is flowing through the ammeter, I can mention that current as IA, and that current is entering at this junction and leaves as IL and also leaves as IV. The current flowing through the voltmeter is called as IV, and the current flowing through the ammeter is called as IA. Okay. Now if you apply KCL, the ammeter reading is going to be equals to IA. What is that IA? IA is equals to IL plus IV. Voltmeter is used to measure load voltage. That is measuring load voltage. That's fine, well and good. But ammeter is used to measure only load current only, na? But it is measuring extra value of current, that is current flowing through voltmeter. Current flowing through voltmeter. Okay, so you are going to get an extra amount of current, and that's the reason why the measured power is going to be more than the actual value. This is the actual value. We call this as true power. The true power is equals to VLIL, and measured power can be taken as now voltmeter reading into ammeter reading. Voltmeter reading into ammeter reading. What is a voltmeter reading? VL. What is ammeter reading? IL plus IV. IL plus IV. Yes or no? Okay. Now if you can multiply, or if you can bring out this one, VLIL and VLIV. So this VLIL term is going to be said as true power. So measured power can be taken as true power plus VLIV. I am writing VLIV and an extra power component that is actually called as error component. VLIV is the extra power component. I should actually get measured power equals to true power. If I am using meters, the meters has to give the exact values. But meters are not giving the exact values, but it is giving exact value plus extra component. That extra component, if you add up to the exact value, then it will be measured power will be definitely greater than true power. So VLIV I am writing like this. The current flowing through the voltmeter, I am writing it as VL by RV. So I can take up it as here I can say measured power is greater than the true power. No doubt measured power is greater than the true power. If measured power is greater than the true power, error is going to be positive. Now PM minus PT, this is your absolute error, and that value is equals to VL square by RV. So they'll ask you, ammeter voltmeter method is suitable for measuring high value of load or high resistive loads or low resistive loads. They'll ask you the question as ammeter voltmeter method is suitable for, is it suitable for high resistive loads or low resistive loads or medium resistive loads? Can you tell me what could be the answer? If you want to use ammeter voltmeter method to measure high resistive load or otherwise to measure low resistive load, if you want to measure any resistance, this method has to give minimum error, minimum deviation. This method has to give minimum deviation. So how much deviation it is giving? It is giving VL square by RV deviation. Okay, so this error has to be minimum always. Let it be any method, error should be always minimum. If you want to get error as minimum, how here? Don't try to increase the resistance of the voltmeter, because they are already designed. Ammeter is already designed and voltmeter is already designed, and don't try to increase the resistance of the voltmeter. Okay, so it is, how can you minimize error? This is not a load. If this is not a load, then minimize the voltage across the load. If you can minimize the voltage across the load, then error is going to be minimized. How will you minimize the voltage across the load? If you want to minimize the voltage across the load, it is better to minimize the resistance, load resistance. That is, do not use high resistive loads. Use low resistive loads. On AV method. AV method is best suitable for low resistive loads measurements. The power consumption in low resistive loads is suitable for AV method. Is it clear for everyone? Can you confirm about this? Okay. Similarly, but remember here there is an error, and the error is VL square by RV. Similarly, VA method, let us take up VA method. We know our true power is equals to VL into IL. Okay, and this is my VL and this is my IL. Now I wanted to calculate ammeter current and voltmeter current. Let us calculate voltmeter reading. This is my voltmeter, and this voltmeter is going to read voltage drop across ammeter and voltage drop across load resistance. If you write a KVL, the voltmeter reading is equals to VL plus VA. Ammeter reading is equals to, I can take up it as actually IA, and that IA is equals to IL. Now if I am writing the power measurement will be voltmeter reading into ammeter reading. We are going to get VL plus VA into IL. So the measured power is equals to VL into IL will be VLIL plus VA into IL will be VA into IL. Now this is your true power actually. So measured power is again greater than the true power. Measured power is again greater than the true power. Now if I solve measured power minus true power, then I will be getting this as absolute error, and that is I am getting VA into IL. How can I write VA? I can write VA as IA into RA, the current flowing through the ammeter into resistance of the ammeter. So current flowing through the ammeter is IL into RA into IL. Okay, so now I will be getting the absolute error as PM minus PT, which is equals to IL square into RA. Now again the same logic here, we need to get minimum error. How do you get minimum error? If the current is lesser, or otherwise if the resistance of the ammeter is lesser, you will get minimum error. But the point is you cannot change the ammeter resistance once they are designed. Now the point is only here you can minimize the current flowing through the load. How to minimize the current flowing through the load? Increase the resistance load. Increase the load resistance. That is, use this load resistance as very high. So if you use high resistive loads, maybe kilo ohms, mega ohms, then the current flowing through that load will be minimum and the error is also minimum. So voltmeter ammeter method is best suitable for VA method. VA method is best suitable for high resistive loads. Okay. Similarly, AV method is suitable for AV method is best suitable for low resistive loads. Okay. Now let us calculate the error here also. Here I have got the error. This is the error. Okay. So the error in ammeter voltmeter method. I have got it as VL square by RV. The error in voltmeter ammeter method, I have got it as IL square into RA. Now the question is, they'll ask you, okay, so ammeter voltmeter method is suitable for low resistive loads. Voltmeter ammeter method is suitable for high resistive loads. Okay, low resistive loads means, less than kilo ohms, maybe in the range of hundreds, 200s. Okay, 100 to 500 ohms you can measure. High resistive load means greater than 1 kilo, like that. On the other side, generally for the medium resistances, these methods are suitable. Medium resistance range is what? Medium resistance range is 1 ohm to 100 kilo ohms. This is a medium resistance. So on the lower side, AV method. On the higher side, VA method. If the resistance is a lower value, use AV method. If the resistance is a higher value in this range, use VA method. Okay. Now the question is, they'll ask you, in both the methods you are getting error, no doubt. Where, at what point of load both errors are going to be equal? AV method is suitable for low resistance. VA method is suitable for high resistance. Okay, right, fine. In AV method, if I use little more resistive load, then error increases. In VA method, if I reduce the load resistance, error increases. Okay. So somewhere at one point, both the errors are going to become equal. So here, error in first case, error in second case. At what load resistance? At what RL? E1 is equals to E2. I can equate them, VL square by RV and IL square into RA. If you write VL by IL whole square is equals to RA into RV. So VL by IL is equals to RL, and this will be root of RA into RV. Geometric mean of ammeter resistance and voltmeter resistance. This is the point where both the methods will give equal errors. At what load resistance? Error in the AV method, error in the VA method are equal. So this is the load resistance. They'll give you some values. Ammeter resistance is of this much 0.2 ohms, voltmeter resistance of 5 kilo ohms, like that. And then they'll ask you to calculate at what value of load the errors are going to be equal. Okay. So remember, the points you need to remember here, it is AV method is suitable for low resistive loads. VA method is suitable for high resistive loads. Okay. If you want to remember, ammeter is first. The ammeter internal resistance is what? Low, na? Here voltmeter is first. Voltmeter internal resistance is what? High, na? So high resistive loads. Ammeter internal resistance is low resistive loads. You can remember like that. Okay. Is it clear? Alright. So that's all about today's session. So this is all about app classes. On app classes, you will be having an advantage from the YouTube class, because whenever the app session is conducted, like we will try to ask you some questions and we'll project the leaderboard. We will project the options. So if you participate in the options, you can score. So it's like live feeling, like live. You're writing a live exam like that. So on the spot, we will be projecting the score also of that particular student. Okay. So it's like an exam feel you will get. So there is a crash course announcement for the GATE 2024 aspirants, like those who are planning for GATE 2024, whether it is ECE or EE or mechanical, all the branches we are launching crash course. So if you are interested, you can come and join with us. We are here. We are going to refresh or brush up the fundamental concepts and basics which are necessary to crack the GATE examination. Okay, so that's all about the GATE crash course program. And coming to this Telegram channel, if you have any doubts or if you want any help, if you want any notifications or if you want any PDF materials, you can join this Telegram channel so that I'll try to upload all those things here. You'll get an updates from this Telegram channel. All right. So if you have not yet subscribed to the BYJU'S Exam Prep channel, so please try to subscribe. Hit the like button, click on the bell icon, and subscribe for the notifications, so that you'll get notifications whenever any class is going on, any important updates are there, you'll get a notification from the BYJU'S Exam Prep YouTube channel. Okay, thank you so much, have a nice day.